to start today, if you don't already have a deck of cards from the front, grab one, please. So there's tons of them. And go ahead and open them up and, remove the jokers, put them aside, that sort of thing. And we'll talk about what we're going to do after you guys get them unpacked. Huh? Oh, these were pretty cheap. I just bought a bunch on Amazon. They were maybe like 10 or 12 bucks a piece. So nothing horrible. Okay, the other thing is if you've got your computer in front of you, great. If not, fire up the classroom one and get logged into it. And then also either get out your phone or a watch or some sort of timekeeping instrument. So take a minute to get all that going. So go ahead and get onto the Canvas page and get your timekeeping instrument, some scratch paper, although actually you can use the, we're going to do some stuff with Google Sheet. So yeah. And the deck of cards, hang on to these for the next week or so because we're going to keep using them. So there's no reason to just keep them and keep them with you. Okay, so what we're going to do is we're going to start talking basically about algorithm analysis and sort of how you could measure how much work it takes to do a particular algorithm. And probably one of the most, well, let's say common kind of algorithm that you might need to deal with a computer would be searching for something or sorting things, right? So we'll kind of use sorting algorithms as our kind of running example for this. So if you've got your deck of cards here, right, all 52 of them, and you've pulled out the jokers, and some of these decks of cards come with like instruction cards, right? So pull all that stuff out. So you've just got the usual 52. And then what we want to do is, well, if I asked you to sort all 52 cards, okay, right now, that would be very easy because you just opened the box, so they're all already in some semblance of an order, okay? All right, so first thing is just take out one of the suits of cards, doesn't matter which one, okay? Spades, diamonds, hearts, clubs, whatever. Just take one of the suits and set everything but that suit of cards to the side. So you need to set. Okay, so like I said, it doesn't matter which suit you pick. Just pick one and set it to the side. Okay, so what's the standard order for a deck of cards or for a suit of cards? Yeah, okay. So that you can do that. You're right. There's kind of two standard orders, right? It's basically the question is where do you put the ace, right? Do you take it as if it's a one, or do you take it as if it's higher than a king, right? It doesn't really matter for our purposes. Just pick something and stick with it. Okay. So so the cards as they come have the aces before the two, so that's probably just as good of an order to keep, right? So ace is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the jack sort of counts as 11, queen is 12, king is 13, right? 13 things. Obviously, that's not their value in like blackjack, but just right there's. Let's just basically think of these are the numbers 1 through 13. We just have assigned Jack to 11, Queen to 12, and King to 13. Okay, so make sense? All right, so if I asked you to sort the suit that you have in your hands right now, then there's nothing to do, right? They came sorted pre in the box. Okay, so now shuffle them. So shuffle up your suit of cards. Uh, you know, you don't have to be really all super good at it, right? But just shuffle them up, um, the single suit, uh, and then put them face down, uh, and get your timekeeping device ready. Okay, now on Canvas, if you scroll down on the main page here, there's a, let me make sure it actually published. There's a unit or one of these module things that's called algorithm analysis. And there's a link there to a Google Doc that we're going to edit as we go through this together. Okay, so find that, the card sorting spreadsheet, okay, and open it up. And like I said, it's a Google Doc, so we'll all be able to edit it collectively. Okay, so what we're going to do is, so get out your timekeeping device, your phone, whatever you're going to use. Okay, and now that you've shuffled up the cards, I want you to sort them into the order that we said, ace, 2, 3, blah, blah, so on, Jack, Queen, King, okay? And write down the number of seconds that it took you to accomplish that, okay? Now, I am not telling you guys how to do the actual sorting, right? That's up to you. Like exactly what method you're going to use to sort the cards, okay? There are lots of different algorithms for sorting, and we will kind of talk about that. But for right now, just sort them however seems logical and natural to you, okay? All right, and then we're going to do this 5 times, okay? So, so make an entry there for your name in one of the columns, and then T1 through 3, 4, 5 will be where you'll put your number, and all you're going to put in the box is just the number of seconds. You don't need to put seconds. So if it takes you 10 seconds, just put 10, okay? All right, make sense? All right, we'll get to it. Let's start doing it. Oh, and then obviously shuffle each time you repeat this, right? Because otherwise we're not going to have very interesting data. And I have to say, if there's anybody online, this is genuinely pathetic, the audience today. I mean, not that I should yell at you guys because you're all here, but where's our favorite? Well, I guess he'll be doing some push-ups. Yeah. Did you guys have fun with that recursion homework, by the way? Told you. Told you it was going to be fun. I'm going to go with you're really slow. Oh, and who had to go in and leave a blank space? Hey, Cody and ZU, put your stuff up one row because there's that blank. Okay, yeah, just move your stuff up one row because it's throwing off the average computation. There we go. Hmm? Oh. Hmm. Je ne sais pas. Oh, and make sure on your way out that you properly dispose of all the detritus from your cards, all this plastic, bro. Oh, and fair warning, if you're going to go to breakfast after class, Cody, what might you need to take with you? Mm. You know, Cody, I'm really not sure how you managed to fit this thing up there, but you sure did. Hmm. Right. No, you save that one for beating. You can, you have to provide your own stick for that. So, okay, looks like we're getting close to having everybody done here. Um, yeah. Okay, I guess you just fail. Yeah, that's some excuse going to weddings and good morning. Have a seat. We were just talking about you. You'll need that. Hmm? Yeah, they're all new because I just, you know, you can open it. So, all right. So, let's see. Julius, are you getting there? All right. And Slowpoke ZU, huh? Oh, are you sorting all of them? No wonder. Okay. Sorry. I wasn't clear. You were supposed to only sort these. That's why your numbers are all off. Okay. No, don't worry about it, ZU, because we'll need those numbers in a minute. Okay. So ZU, write down your numbers, and then because I'm going to delete your row in a second, but we'll use those numbers in a minute. So just so keep them. We just don't need them right this instant. So yeah, so let's as you guys are almost done filling in the your entries, let's kind of talk about what would account for the variability that you're seeing in the numbers. Okay, so so what are we seeing for um, our average for doing this with one suit is about 15 seconds on average. Does that seem pretty reasonable? Okay, and ranging from what's the fastest time that we had in any of these? Yeah, 8.2 seconds, right? So anywhere, so the range though, right? If we look at our averages, uh, the average of the averages was 15 seconds. Um, and the range of averages was from anywhere from basically 12 up through 25. Okay. So what accounts for the variability here in terms of these numbers? Okay, what explains why you guys didn't have exactly the same numbers every time? Yeah, so some of it is the shuffling, okay? How, like, if you shuffled your cards, is there a chance that they could end up just exactly sorted? Now, that's a pretty low chance, but it could theoretically happen. And maybe you got lucky and like three or four of your cards already happened to be in order just after you shuffled them. So that could happen. Okay, what else could explain the variability? Yeah, Cody. Yeah, okay. And at 8 in the morning, right? Not everybody's fully awake yet. Maybe you haven't had coffee. You're running on fumes. Maybe you were the guy that dropped the tab last night and had a pulled an all-nighter. So, yeah. Yeah. You've just got the face that kind of looks like it, right? I mean, it could be worse. You could be in a certain fraternity. So, yeah, anyway. Well, yeah. Uh, okay, so yeah, how awake are you? But also the method by which you went through and sorted. Okay, so I've deliberately not talked about the actual sorting algorithm. Okay, but you could kind of do this. You could go through and find the ace and put it in the front, and then search through the whole deck and or thing, and then find the two, and so on. Now, would that probably be a little slower than, well, how did you guys do this? How did you actually implement the sorting? Huh? And then just kind of moved them around? What else? Did anybody go through, find the ace, put it down, and then find the two, and then so on? Okay. Well, anyway, we're essentially what we're doing here, right, is sorting a random pile of numbers that's 1 through 13, and there are a lot of ways to do this. Okay, a lot of sorting algorithms. We'll talk about um, a couple of them sort of formally on Wednesday, but for now, right, it could be the case that Cody was using a different algorithm to sort them than somebody else. So, like if we had Cody's evil twin, then maybe Cody's evil twin uses a different algorithm than their same person. They're just doing it a different way. Okay, so what's sort of the idea then for the rest of our data collection? What do you think we're going to keep doing? Yeah, okay, so now add a second suit to the mix and shuffle them. Okay, and when you add the second suit, okay, here we have to make a decision. Let's say that you've got two suits. What's the order in which we're going to put them? And there's a couple ways we could go here. Doesn't really matter. Okay, what would be one logical order? Yeah, split up the suits. So you've got, let's say you've got a black suit and a red suit. Okay. Now, obviously, eventually this won't work, but if you've got two different colors, then could you easily pretty quickly sort them into the two different colors and then sort each one individually? That would certainly work. Okay. What would be maybe a different way of doing it? Yeah. I'm sorry. Yeah, that would be the logical thing, is to put them in suit order. Okay, so what is the order of the suits? So, what's the lowest value suit? Clubs, followed by, I believe that's right, yeah. Diamonds, then hearts, then spades. Okay. Um, so you'd put, say, all the clubs first and then all the hearts, or whatever two you've got. Okay. All right, so makes sense. Now, when you do this, you're going to shuffle all 26 cards together. Okay, so they're going to be in randomized. It's not that you have two different sets of shuffled cards. If you had two different sets of shuffled cards, we would expect to see exactly twice the numbers that we've already got, right? Because you got twice as many suits. Yeah? Okay, but it's going to be more than that, right? Because all of them are jumbled up. Okay, so again, go through, and in this second little chunk, let's put the number of seconds it takes to sort two of the suits that are shuffled together. Okay, got it? Good? Hmm? That's up to you. Okay, get them sorted. So let's say, which suits do you have? So do all of the clubs and then all of the spades in the appropriate order. Okay. Um, you could, if you want to do ace, ace, 2, 2, 3, 3, right? That works too. It doesn't matter. It doesn't matter. Just pick something and be consistent with it. Okay. You guys, I'm gonna go refill my water. Okay, so obviously this will take a little bit longer than um, than the last one. Hmm. Oh, yeah, so just add it. I'm going to have to move the averages down. So put it on the line underneath ZU. And the link for this is on Canvas. Oh, well, I guess you fail. Man, you're getting intense there. Yeah. Yeah, well, I thought about putting something a little more mean, but we are live streaming this to the entire internet, so got to keep it somewhat clean. Don't want to get Twitch banned because that would be bad. Yeah, but then I'd lose all my play counts and views and followers, and I'm making bank off of the ad money. Okay, so data's coming in. Looks pretty reasonable. Okay, so it looks like we're getting pretty close to having all the data in. Um, so we'll just finish the sorting that you're on, and then we'll move on. So it's okay if you don't get all five. Okay, so what do we notice here? What'd you guys notice? Okay, yes, the average is in fact bigger. Okay, that by itself is not surprising, right? But what maybe is surprising about the average number? More than double. Would you guys have expected something more along the lines of 30 seconds? Okay, why is it more than double? Yeah, right. Okay, so if you were approach this from the standpoint of you're going to separate the two suits and then individually sort each suit, well, individually sorting each suit would take on average about 30 seconds for the two of them, right? But it takes you some amount of time to get the two suits sorted, the red ones here, the black ones there, or whichever you did, right? That also takes some time. Okay, now, did anybody do ace, ace, two, two, three, three, and so on? Yeah. Okay. Did anybody besides? Yeah. Okay. So in your case, then, what were your numbers, rough relative to what they were before? What was your average each time? 30. So you went from 13 to 36. Uh, is that right? Yeah. Okay. So again, though, more than double. So why do you think that is? That it took you more than double? Right. Okay. So depending on exactly how you did the sorting, and like I said, um, there are different algorithms for sorting, and we'll talk about that on Wednesday and kind of look at how they work, how some of them work. But exactly how you did the sorting, even though you were doing ace, ace, two, two, three, three, how you went through the cards, did you go through and find the both aces? Okay, so you would put it either to the right of the eight if it was greater than, or to the left of the eight if it was less than, and then you just, and then there you go, right? Okay, and then you'd continue. Okay, so yeah, that kind of makes sense, right? But it's still going to take you more than twice as long. Okay, all right. So what do you think that we're going to do for the next thing? Okay, add another deck or suit in. Okay, so now there's three suits, and repeat this. Okay, now maybe doing this 5 times is a little bit excessive at this point. Just do it. Just do it twice, because it'll obviously take a little bit of time, um, and our data won't be as reliable just because we won't have as many samples. But we'll get the idea as to what's going to happen. Okay, so. So ZU, since you've already done 5 of them, go ahead and throw the, or 4, or however many, go ahead and throw those in. And everybody, try and do at least 2 of them, um, just so we have, oops, just so we have some data here. Ah, you're realizing more workspace makes this faster. Plus, Kiani stinks, so you got to watch out for them New Yorkers. Speed demon. What's this with G? You guys are just slow pokes. Yeah. Or maybe he just sucks at shuffling. I don't know. Right. Yeah, I mean, there is sort of a randomness to this whole thing, which is unavoidable. Um, and this is why I'm having you guys all do this, and then we're averaging all of this stuff, is to try and sort through that noise. Huh? You can't be that slow? Sucks to suck, man. So, any guesses as to what your homework assignment's going to be? Yeah, I've got like um, copy paper boxes full of cards, and each one they're all in the closet there. Each one of you gets an entire box full of cards. No, I'm kidding. That would be awful. That'd be character building. Yeah, exactly right. Find some pledges and make them sort the cards. Yeah. Now, because what we're going to do on Wednesday is we'll talk about actually like how would we make a computer do this job, right? Which will mean that we'll have to talk about actually how are we doing the sorting. Um, and then we can make the computer do this 10,000 times and compare the results of 10,000 trials to see what we get. And obviously take less time than Mr. Hearns. You think you can get something on the board? Did you not put it in? What was it? 82. Just because otherwise we won't get an average. Oops. Okay, so finish the sorting you're on because it's almost 8:50. But what are we basically noticing about the numbers? Oops, looks like I've got a typo in my formula. Okay, what do we notice? Okay, so what was our average this time? 72, 73 seconds, basically. Does that seem pretty reasonable given how long it took you to do this? Okay. So again, what would you maybe have expected to be at the bare minimum 45 seconds? Okay, and how did I get 45? Well, isn't this at least 3 times as much work as doing it for one suit? Okay. Um, Now, in this case, there is maybe one additional wrinkle because if you've got 3 suits, like how many of you guys, when you did this with 2 suits, you did one black suit and one red suit? Okay. And doing it with one black and one red suit probably made it really fast to separate the red cards from the black cards. Okay. But what's the problem with this time when you're doing 3 suits? You got 2 of the same color no matter which ones you picked, right? This is the pigeonhole principle. Um, and so if you were going to approach it from the let me sort the 3 suits by the into all the clubs here, all the hearts there, and so on, right? That would be a little bit slower this time around than it would be if they were of different colors. Okay, um, but in particular, what we notice is that it's definitely more than 3 times the amount of work for uh, the the one suitcase. Okay, so since we're basically out of time, what do we want to do basically before you guys get to class on Wednesday? What would I like you to have done? Yeah, go through and fill out all of the remaining data. Okay, so in particular, you're going to do however many instances of 3 suits that you didn't quite get to today. Okay, but then also all of the 4 suit data. Okay, where you're sorting the entire deck basically. Does it make sense? Okay, so please have all those numbers in on the sheet, and if you need the link to it, again, obviously it's still on the Canvas page if you were using one of the classroom computers or something, so you can get back to it. Keep your cards. Obviously, you'll need them for this. And any of this plastic wrap that came on the cards, if you would be so kind as to put it into the waste receptacle. All right, so what we'll do on Wednesday is I'm going to make some graphs based on the data that you guys get. So if you could have all of the data in by, say, the end of the afternoon tomorrow, so that tomorrow night I can make the graphs, that would be great. Okay? Yeah? All right. Get her done, and I will see you guys on Wednesday.